All right. Hello, everyone. Good evening.
Evening.
Yeah. All right. So I will start sharing my screen and yeah. Okay. So I think you can see the screen now. Okay. So we are done with 7 sessions for this course. This is the 8th week. And so we are like almost 2/3 into this course. So we'll just proceed as usual. We'll first discuss what was discussed in this week, have a quick summary, try some practice questions, and then take a look at the last week's assignment. But before we do you have any questions in general, or any doubts, or you have any suggestions to improve this live session? Anything at all?
Yes, I wanted to ask, where can I access the other live sessions that happened before this one?
Okay. So so if you take a look at your I think I should have this open. Yeah. So if you take a look at this one here, problem solving session, the last option in your in the course outline. So this link, if you see here, okay, no, this one's feedback. Yeah, this one, sorry. The recording, when you click here, you will have access to this sheet, right? So here I've uploaded all the YouTube links, and this is the presentation folder.
Oh, I see. Okay.
Yeah.
Oh, thank
All
you.
right. Yeah. Okay. So this Google Drive link and this channel of mine, this is going to stay the same. So, and yeah, I mean, this you can access from the course page itself. And yeah, so if there's nothing else, and since I mean, before we begin, so I'll just show you the we'll start discussing this. And again, just so the way we are going to go for this is so I have this R script with me. So I hope now you are able to sort of understand what is the difference between this R script here and this console here, and there's this environment, and there's this pane, the final pane here, which has a lot of options, right? So basically, thing is, we are going to start writing commands today. We'll initialize some variables. We're going to see some outputs and all of that. But then it's not possible. I mean, it'll just take more time if I type everything at the moment. Okay, maybe I'll have it noted somewhere with me, right? I can't remember all of it that I want to discuss. So I have this thing noted down before, and we'll just take a look, walk through this one by one, right? So this is exactly why we would need an R script also, right? And so yeah, I'm just summarizing all of this because it's been a while since we discussed these details. Right, so you can see here there are a lot of lines here which begin with a hash symbol. Single hash, double hash, they don't make a difference for this purpose, but these which appear in a different color here, they're basically comments, right? So even if I copy the whole thing and I paste it here, or I just run it, nothing is going to happen, right? Because it's R say that if a line starts with a hash, I'm going to consider it as a comment. I'm not going to execute it. All right. So, all right. So we'll start off with this week, and there are two seemingly similarly designed variables, vectors, and lists. So I think in the initial few lectures, I have alternatively referred to lists and vectors. I've not been very careful with the words, but in the first few lectures, until like I think even before until week 6, lists were not introduced. So everything before that was vector. And since week 7 onwards, we've been discussing lists. All right. Okay. So, so the simple way, so let's first talk about, okay, yeah. So I just removed this line from here. So I'm pressing Control L. So that clears the console. Okay. And you can also use this broom symbol to clear it. Okay. So just starting off with what are vectors to begin with. So we can take these two examples, okay? So, right, so this is one way you can make a vector, right, using the colon. Another way that you can do it, so instead if I would have written it something like this, then that is also a vector, right? So these are two ways, either the combine function, C short stands for combine, or the colon. These are two ways. The other way was also to use the function seq, S-E-Q. Okay. All right. So this was discussed. This is what vectors are. And now we'll take a look at some lists. So how can you make a list? How can you define a list? The function is list. And if you take a look at what goes inside these brackets, it can look to be very similar to what you can write inside the combine function, right? So I'm just going to copy this thing. So now you can see if I write something like this, this is what a this is what a vector looks like, right? A series of 3 elements, that's it. But on the other hand, if I would execute this command, and you can see right here, it says it's a list of 3. Whereas for these vectors, it does not say anything, but it just tells you it's numbers or integers like that. And if I, okay, just a second, I'll just increase the font. Yeah. So if I see what X looks like here, so you can see now there are 3 elements, 1, 2, and 3. And here, so here they were actually written with a single square bracket. Now here, these broad 3 elements, their indices are written in double square brackets. And within each of this, so this is the first element, this is the second element, and this is the third element, right? So that's what it is. And within each broad element, there's a single element. So this is why this is 1, the first one. There's just one within the first element, and that's apple here. There's banana and orange like that. Okay. Similarly, if I execute this one, y list 1, 2, 4, this is also going to look very similar to what we just saw in case of the names of fruits. It's also like that. Now, if I execute this, so let's say list, curve brackets, and within curve bracket, instead of writing 1, 2, and 4 separately, I'm writing 1, 2, and 4 combined. Can anybody think, can you think what would this be? Would it be the same as y, or would it look something different? Any
Thinking
guesses?
it would look the same.
It would look the same. Okay. Anybody else? So, what is happening actually is that here 1, 2, and 4 are being considered as different elements. They're 3 different entities. But now this becomes a single entity. The combine function has combined these 3 into a vector, and that vector, that single vector, is being fed into the list. So these 3 things are actually, sort of like the first element. So if I execute this, and if you take a look at what Z looks like, you see, so Z has just one element. The first element and the only element is a vector, and this vector has 3 elements in it. So this 1 square brackets is the index for this one. This is the second one. This is the third one. All right. It will become even clearer when I execute this one. So now you see I'm making a list. The list has this vector as the first element. This is the second element here. This is the third element. It's the fourth element. And this is the fifth element. Okay. So now you see, right? First, second, third, fourth, and fifth. Right? Does this make sense now? So this is, I mean, what it is. So you can see that there are some differences between vectors and lists, and in fact you can make it like so let's say instead of this 4, if I would have written 1:100, let's say, right? So now you see this is actually a vector, even when it's not like this is a single entity itself, right? So when I execute this, see what's happening here. So right, so the first element of the list is a vector, a 3-element vector. This is a single element, this is a single element. The fourth element of the list is a vector with 100 elements in its own, right? And the fifth element is also a 2-element vector. All right. Okay. Now, so there's a function list. So there's a sort of opposite function unlist, right? Now, what it's going to do is it's going to remove, basically it's going to remove this demarcation. Okay. And it's going to bring, it's going to put everything one below the other. So let's see what I mean. So, so let's try with this unlist W. All right. So you remember there were 5 elements. This is first, second, third, fourth, fifth. Now if I write unlist W, so you see what happened. Okay, first of all, so this was the first element. This was the second element. This was the third element. This was the fourth element. And this was the fifth element, right? So everything came one after the other. So the total number became 1, 2, 3, 4, 5, 105, 106, 107. So if you see the total here, it's going to be 107 elements. Another thing important to note is in this list, these were numbers. This was also a number. This was also a number. Fourth is also a number. But the fifth one was characters. And one being a character did not affect the other being a number, right? One did not change the other. But in a vector, that's what unlist is doing. When you say unlist, a vector can only have one of the two types. It can only be a character vector or it can only be a numeric vector. Now, characters cannot be converted into numbers, right? If you're writing apple, apple as a number does not make sense. But 2, the number 2 as a character makes sense, right? You can just write 2 in double quotes. So that's what is happening here. So you had all of these numbers, but they got converted into character because there were at least some characters in this vector. All right. Does this make sense? Right. So now if I, so now you see this was the list X. Now, if I do unlist X, can you tell me what the output should be? You can just unmute yourselves. I think typing is going to take more time. This is the list X. Can you tell me what would be the output of unlist X? No? Is it not clear? Hello. Would you like to guess? Anybody? It's going to be in a single line. That's correct. Right? So it's going to, so what unlist does, it converts a list into a vector. And a vector, like you said, it's going to be a single line. But a better way to describe it is going to be that it's going to be 3 elements. So it's not going to be three elements, three different elements of a list, but it's rather going to be three different elements in a vector. Okay, so unlist x. So this is how you write a vector, right? This is how this vector A was written. It just looks like that, right? Okay, good. Please make the class more interactive, all right? There are very few people, so this is a problem solving session, right? It's a doubt clearing session. If you're stuck anywhere, I don't mind teaching this again. All right. Okay. So this is all right. Yeah. So now this C function that we have seen, right? So normally we have seen this function in terms of, let's say if we saw it for here, for example, we have three different but single elements, right? Three single numbers or three alphabets. I mean, three words, something like this, right? But now you can use the combine function on something other than these simple variables. All right. So first example here is you have two vectors, right? So A is a vector, B is a vector. Can I combine these two vectors? So C function combines numbers to give you vectors, right? Now, can you combine two such vectors and give you a third vector? Do you think that can work? Any idea? Anybody? Give it a try. It's okay if the answer is wrong. Yeah? No? You don't want to try guessing? I'm audible, right? Yeah? Okay. Give it a try. What do you think is going to happen if I write C, A, comma, B?
Well, I think usually we can combine like two vectors, but I don't think we can combine like the T has more elements. So I don't know how this will execute.
Okay. So now the combine function, for example, when I'm writing 1, 2, 3, what it's doing is basically putting whatever I've written within the combine function one after the other. That's what the function does, right? So now if I'm doing A comma B, so A is 1, 2, 3, 4, 5, 6. It's just going to put the B vector after it. So 1, 2, 3, 4, 5, 6, 11, 12, 13, 14, 15, 16, 17, 18, 19. Right? See this? All right. So it can work. And likewise, if I have matrices, so again, let's say this is a 3 by 2 matrix, right? 3 rows, 2 columns. And here I have a 3 by 3 matrix. Okay. Now, if I combine two matrices, now we know about matrix. So we have talked that if you want to add two matrices, they should have the same order, right? 2 by 3 plus 2 by 3. So you can basically do an element-wise addition or an element-wise multiplication and element-wise any of the four operations. In case of matrix multiplication, there are some different rules that it's going to be, if it's an m times n order matrix, the other matrix should be n times p order matrix, right? So there are specific rules about matrix multiplication, matrix operations. That we've seen. But if I say I want to combine two matrices, if I want to combine, I should say the elements of two matrices, do you think there is a way you can combine matrices? And what do you think should the output be? This is not very intuitive. So just give it a try. Can you think what is going to happen? Right? This is M and this is N. Okay. Is there a way in which I can combine the two matrices? I'll give you a hint. The hint is that matrix, this operation, this function, does not give matrix as the output. Okay. Now, do you think if I think some of you have attended the last couple of lectures, this live problem solving session, and we did see that somewhere a matrix was being read as not being a matrix. It was being read as a vector, right? So can you think something from there? Any guesses? You have to be a little more interactive. Yeah, sorry, say that.
Well, I think it's because of the combine function. It basically outputs a vector.
Yeah, it is going to output in vector. And but now what is the vector going to be? What order in which the elements are going to be read? Are they going to be read column wise, row wise? Are they going to be read the way they were fed into the matrix? So yeah, here too it's going to be a single line output, correct? So it's going to give you a vector as the output. And now the thing is, so a matrix, when you are reading a matrix, it is being read column wise. So first it's being read. So this matrix, irrespective of what was the input, now the matrix is this. So whether the input was to fill the matrix by row or whether it was to fill it by column, it does not matter. This is what your final matrix looks like. And the matrix is read as 1, 3, 5, 2, 4, 6. And this matrix here, it's also going to be read column wise. And it's going to be read as 11, 12, 13, 14, 15, 16, 17, 18, 19. And this output, and if you see, right, so the output from both the things, they look similar. I mean, they're going to have the same number of elements, but of course, the only difference here is that this matrix was actually read column wise, right? So not to get confused by what the original A and B were that were used to make the matrix, but the matrix is read column wise. So when you're reading a matrix column wise, you're basically making a vector, right? A vector is like just a sequence of numbers in this case. So you have two sequence placed together. That's it. That becomes this thing. All right. And now we also have these two lists here, right? We have X and Y. So these two lists, right? Now can I combine these two lists? Okay. So now if I combine these two lists, this does not become a vector. These remain a list. These are just two lists, one below the other. Okay. Right. So basically what we have seen until now, yeah. So this means that see, when you're doing the combine function on a vector with a vector, this is going to give you a vector, right? Then the combine function on a matrix with a matrix, this is also going to give you a vector, right? But the combine function on a list with a list, it gives you a list. All right. Are we okay till here? Yeah. Yeah. All right. Good. Please, if there's anywhere you're stuck, please just, unmute yourselves, write it in the chat box. Either way. Okay. So now in the last thing, the last example that we saw that you're basically adding something at the end of first list, right? First list and something added. So this sort of a thing can be necessary a lot of times. Maybe you don't have to add two lists like one below the other, but you might just want to add some elements one below the other. So there, this function append is going to be used. So append, by definition, it means to add at the end. Okay, so that is what this append function can be used. So now if you see, we had this we'll take two examples, one from vector and one from list. So if I want to add something at the end of this vector, okay, so let's say I want to add 5 at the end of this vector. So basically I just want 1 2 3 4 5 6 5. If this is what I want, and this is I'm getting, right? So append, the first argument is going to be adding to what, and the second element is what to add. All right, so this is quite okay. Now I can also add a non-numeric argument. In this case, I'm adding a character argument, like a character element. But now, like we discussed, vectors can only have one sort of element in them. So if I am going to add a character to this vector, everything is going to become a character, right? So you see, it's still doing the right thing. It's adding this hello at the end of these 6 elements, but it's also converting these 6 elements into characters, right? Because it is now effectively becoming a character vector. Okay. Now I can add this element, or whichever element I want. I can add it at the desired location also. So if I want to add it after 1, that means I want it to become the second element, then I can just write an extra argument here after. So by default, when I'm not specifying after here, it's going to add at the end. But if I specify, it's going to be added at the desired location. So I said after 1, so it's added after 1. Okay. Now, instead of taking the example of vectors, I can do the same thing for lists, right? So this was my original list. It had 3 elements. Now, if I say I need to add 5 at the end, so you see it's 1 2 3, 3 elements, and the last element is 5 here. Likewise, I can add the last element. I can add a character. But now you see, like we saw initially, that a list can handle different types of elements, and one is not going to affect the nature of the other, unlike vectors. And here also I can add it at the desired location. So this one here, right? So my original list was 1 2 and 4, and but after the first element I'm adding a new element, which is hello. Okay, great. So this is how you can modify. This is in a way an example of modifying a list. Now if you remember, there were uh, cases where we had seen that you can access the list through its access the vector through its indices, right? You want to extract one element, you want to extract multiple elements, you want to remove some elements. So all of that you are basically doing through the use of square brackets. Now you can do something very similar for lists also. Okay. Now, basically, if I have, so this was my vector B, right? So if I want to extract just one element out of it, let's say I want to extract the third element. So I'm just going to write 3 like this, right? So I get the third element. Okay. Now, if I want to extract the third element from a list, okay, so we had initially, like in one of the previous lectures, we had seen that this is how you can extract the third element, right? So yeah, so this was the third element, right? Now if you're extracting this whole bit, if the highlighted region is, if that's what you're taking, then okay, let me show you something. So I have this, not B, sorry, W and this thing. right? So the third element of W, it's a single element, that's 2, right? Can somebody try to explain what is the difference between these two outputs? Do you think you can see some sort of, there is a difference, right? There's this big one that's extra here. So can you think what difference is happening here? Why are these two outputs different?
Yes, I believe the first one is a list and the second one is a vector.
Perfect. Absolutely, right? So if I save this, let's say I'm calling this Z1, and if I call this Z2, so you see here, Z1 is a list, but Z2 is a vector, or in this case, it's just a single element, right? So this thing, wherever you are seeing double square brackets, you can say that it is a list, right? Okay. So now if we are saying we want to create a sub list, okay, so then basically we are extracting an element, we or maybe one or more elements from that list, but we still want to retain the list structure, right? So in that case, we'll just use a single square bracket. But if we are doing a double square bracket, we are basically sort of removing the list nature. We are just extracting one sub element of that list. Okay, this will become more clear when we take example of two elements. Okay, so now I want to extract the second and the fifth element. So in case of a vector, this is fine, right? This is easy. This is what you've been doing. But now actually in case of yeah. So now in case of this list, so if I just write a single square bracket, so you can see that it is still a list. The list has two elements, the third element of the original list and the fifth element of the original list, right? But now if I try and do this, then it's not going to work, right? Because within two square brackets, I cannot extract two elements. When I say two square brackets, I have to individually focus on just one of the sub elements. All right. So again, if you want to create a sublist, whether that sublist has just one element or multiple elements, but if you want to retain the nature of the sublist, you have to use a single square bracket. Okay. So to retain list structure for one or more elements, use this. And the second option is to extract one element and sort of to lose the list structure, use double square brackets, right? Okay. Now the same thing, instead of when you want to extract something, if you want to remove some of them, so it's the same thing, right? If you have 5 elements and you're say, I want to remove the fourth element, then you're basically selecting 1, 2, 3, 5. Right? This is something we have seen before also in case of vectors, right? So for example, here, so this was the original vector. If I say I want to remove the third element, then basically I am selecting all the other elements. So that's right. That's completely synonymous to that. Now, likewise, in case of lists also, it's the same thing. You want to remove one, but you want to retain the list structure, so you have to use a single bracket only here, right? So something like this. So now you see in this vector, the third element, which was, I think it was the number 2 only, that is removed, right? But now here, this thing you cannot do again, because this does not make sense. You can't remove just that sub element 2. Okay. Likewise, you can remove multiple elements also from a vector. You can just specify that within C. So you're basically giving a vector as the input, a vector of indices that you want to remove. And the same thing you can do here also. So if you want to remove both the third and the fifth element of the list, you're giving it in single square bracket. So this is something you should remember. If you want to retain the structure, you give it in single square brackets. Okay. And we already saw that if you want to convert a list into a vector, you can simply do unlist. So then it's just going to remove that whole structure, right? Now, of course, this is also not going to work. So this is what was discussed in the first lecture of this week. Okay, any questions? No? All okay? Yeah, all right. Okay, great. So we take a look at the next week thing. So we have this list W here. Okay, this has 5 elements. And I am also defining one more list here. And if you remember how I defined this list, it was this way. Yeah. So I just said this is the first element, second element, third element, fourth element, fifth element, right? Let's say I'll write it this way. Now I'm defining a very similar list. It is almost identical, except the fact that now each of these elements, they have a name with it. So now you can see the difference. Here you had this list index written very clearly here, but now you don't have that list index. So you don't have the list index in double square brackets. Instead, you have a dollar symbol and the name of that element. Okay. So now you can see here, I want to extract these names. So let's go step by step. If I extract the names from W, it says, no, there are no names. It's 1, 2, 3, 4, but these are not names. These are positions. And likewise, so if I do it for the other vector V, I do have these names. Now the thing is, so W, let's say I write 3. And if I write V3, and if I write W3 and V3 like this. So now you see here, so W3 again, a single square bracket, so it's going to retain the list nature. Okay, so W3 is just a single element list, and which has 2 as the element. And if I use this list, the named list, there also the third element is still this digit 2, right? It can be called by the name E3, but it's still the third element, right? So square bracket 3, it will still give me the same answer, right? This thing. And if I want to remove the list nature, if I just want to extract this element here, then I can just write a double square bracket, same in both. Yes. Now the additional functionality is, if I write this thing, $E3, then also I get the same answer. Okay. So when you have a name of an element, there is an extra way in which you can extract the element. But then that, of course, then you're going to lose the list nature of it. Okay. So, so these are the 3 ways in which you can access a. So yeah, there's this one more way. You can write it like this. Okay. Again, so normally you can access an element using the index with double square brackets. Now you can access it in two different ways. You can write dollar that name, or you can write that name in double quotes within the double square brackets. Okay, so sometimes it can be useful. Sometimes you don't want to remember the position at which the, so it's basically like if you have an Excel file, you can take a look at the column names, right? Which are also called headers. So that part is going to come in a couple of weeks in this course also, where you'll be working with column names and all. But because it's not always possible to remember, was it the 6th column or was it the 46th column? But you remember, okay, the column name was, let's say, years. So you'll say, okay, wherever the years column is, just give me that. Okay, so that's one thing. And now maybe it's just, maybe you want, so let's say here, instead of, so basically you want to change the name. I want to change the first element. I don't want it to be called E1. I want it to be called element 1. So the way to go about it is, so now if I write, so we just saw what names V gives us. It gives us a 1, 2, 3, 4, 5, 6. Now this, can you tell me what is this output? What variable type it is? What is the data type of this? Is it a number? Is it character? Is it list? Is it vector? Is it matrix? What is it? The one that I've highlighted here. This, all of you know this. What happened is, are all of you sleepy today? Are you having some exams going on in your colleges? Yeah. Okay, it is character, but it's not a single element, right? It is a multiple elements. So then what do we call it? Remember? We've been seeing this. Yeah. Not list. List always has two square brackets. It's a single square bracket, right? It's a vector, right? When you have multiple elements, one after the other, but it's not a list, it's a vector, right? We've been seeing this all throughout in the last few weeks also. So now you can access any element of the vector by its index, right? So names V, it's going to give me this. And from this, let's say I want to choose the second element. So it's going to give me this, right? So it's basically, I'm combining two steps. I'm saying names of this, I'll save it in whatever temporary variable. And then in that variable, I'm saying square bracket 2. But instead, I can just combine the two steps. I'll say process this, and then from there you choose this. Now I'm adding a third step to it, that when you have these three things, when you have this thing done, you assign it a new name, whatever the new name is. So now when I do this, now you see the name has changed here, and the name has also changed here. Okay, so what has the step done? That names of V, there were E1, E2, E3, E4, E5. The first of it, which was E1, now you assigned element 1 to that, right? Element 1 assigned to the first name of V. That's how you're going to read the statement. All right, so that's changed. And it's not just about reassigning, but I can also do this same thing for this one. Now you see W here. Okay, so the first one got changed. I did not specify any of the other names. So now by default, it expects that there's going to be name for everything, right? It does not make sense that you're giving name to one. So when you have made an Excel file, you should give, if you have names, you should have names for all the columns. It doesn't make sense that you are saying column 1 is year, column 2 is date, column 3 is day of the week, and column 4 does not have a name. Column 4, 5, they don't have names, right? That does not make sense. So anyway, but it is possible to assign names to vectors. Now think about it. If you want to assign names to, like, if you want to assign names to all the elements of this vector W, can you tell me how we can do that? So this is vector W, right? Currently the names are null. There is no name to this vector. But if I want to assign names, can you tell me how we can do that? Through a list? Okay, through a vector, right? So it's like this. C, let's say I'll write A, comma B, C, D, and E, right? Now you see, these names have been assigned to the vector W. Okay. All right, good. Right. This is slightly new. Okay. The topic is not very simple. So it's not possible to assign names with a list. Okay, let's give it a try. I don't think it will be possible, but let's see. I'm reinitializing this, and instead of writing C, I'm going to write list. Okay, that worked. Yeah, it's worked. So any of the two is going to work. Good, very good. This is right. So it's a hit and trial. Yeah. So either works, right? All right, great. Um. Okay. So now, I think right now okay, so this brings us to an end of the discussion on lists. Okay, just one small chunk, but I'll just give you an example with a vector first. So we have seen here that if you have, let's say, okay, right, so if you have this vector P which has 6 elements, I want to make a matrix out of it. How am I going to do it? I'll say matrix P. So let's say n col is 2 and n row is 3, right? Something like that. This is going to be how I can make a matrix out of it. But there is one more way to make a matrix out of it. And basically what I'm going to do is I'm going to convert P into a matrix. So right now, if I do this, I can save it in a different name, right? Whatever, some different name. So that's going to be my matrix. But if I want to convert P into a matrix itself, so I am basically going to reassign the dimensions of the vector P. So what I'm going to say is dimension P, you assign the value 2, 3 to it. So basically I'm saying, so let's say just for some like equivalency, I'll just say that you convert it into a matrix, you make the dimensions of P to have three rows and 2 columns. So if I do that, now P is this this vector here, 6 element vector. And you see where is P? P is here in values, right? Now if I run this thing, when I'm changing the dimensions of P, you see P pops up here in the data and P becomes a matrix, right? So this is just a different way in which you can make a matrix, right? And again, here it's always going to be column wise. By row, it's false. Okay. Likewise, the same thing I can do for a list also. So if I have this list, right? I have this list here. I'll say that change the dimensions of the list to 2, 2. So now you see this thing. Now, so this is equivalent to that of a vector. But now you see here, this is actually not a matrix. Okay. So if I do this mode of P, it says numeric, right? And the mode of Q here, it actually says it's a list. Now, an important thing to remember about vectors and matrices is that both vectors and matrices can only have one type of data in them. If they are numbers, they should all be numbers. If they are characters, they should all be characters. Vectors and matrices cannot have two types of data in them. But now you see here, you can see that there is two types of data here, right? So even though this looks like a matrix, if you check the mode, it is actually a list. It's just that it is now arranged in the form of a matrix. Okay. So that's why I've written it here that you're changing a vector to a matrix and a list to a matrix-like structure. Okay. And so this is why normally when you're making a matrix from a vector, you will only have one type of data to it. But when you're making a list, when you're converting a list to a matrix-like arrangement, at that time you can only it doesn't matter if you are numbers or characters. But now you remember this complicated thing that we have. Now here you cannot convert this thing into a matrix like arrangement. Okay, give it a try. It does not work. Okay, because these elements, they have to be single element. The length of each element of a list should be 1. Okay. Yeah. All right. Now, one more thing, one more added functionality that this matrix like arrangement can offer you. So now you see here, Q, this is how we have arranged, right? Q is actually a list. You can see this here. Okay. So let's say I want to access this element here, high. So I remember in my original list, this was element 4. Okay. So it's still the 4th element. But now there is another way to access this thing here. Sorry, this one, right? The 4th element or the 2, 2 element, right? But now remember, when I'm accessing the particular element, it has to be in double square brackets. Okay. But of course, this is not going to work, right? Because the original, this list is not arranged. This list you cannot arrange like a matrix. Okay. So not working. Okay. All right. So I think with this, we come to the end of the discussion on lists. Not an easy topic, but you have to try. Just, define a list, try to make some combinations from it, try to extract something, rename it, arrange it in a way. Just give it a try. Have numbers, have characters, have multiple, you can have a list within a list also. Try to make all of this. You're going to understand it. Okay. It comes as you try. Okay. It's there are too many things to be taught, and even if you're taught, it's too much to remember. But once you practice this, it's going to come intuitively to you. Okay. All right. So now I'll just clear the screen, and so I'm going to define another vector. Let's say this vector D. Okay, it's the first 5 odd numbers. So something this is just a summary. This was introduced, and it's a good time to actually, have like a quick revision of this thing that was taught in one of the initial lectures. So now, although I've written it on the right side that what each of these steps are doing, but don't read it and see if you can identify what each of these steps are going to do. Okay, so um I'm hoping that you're going to give me an answer without reading what's written on the right side. So D greater than 4. If I write this, what is going to be the output? Okay, the answers are there, I know. So anyway, so basically this is a condition you are testing. So it's a logical statement. Okay, so it's going to give you true and false as the output. All right, so D greater than 4, false, false, true, true, true. Okay, and if I do a sum of this thing, right, so it's basically doing a sum of true and false. And we have seen that inherently false has the value 2, um, false has the value 0, and true has the value 1, right? So you're summing up 0 plus 0 plus 1 plus 1 plus 1. So that's giving you 3. And that's basically telling you the number of elements that have that satisfy the condition. And if you want to identify which elements these are, rather than if you want to identify what positions are these elements at. So what are the indices of the elements that satisfy this condition? Then you say which. So it's the third, fourth, and fifth element that satisfy the condition. Now, if you want to know the exact value, that is, if you want the third, fourth, and fifth element, then you're going to feed. There are two things you can feed. Okay. So you can either feed it a list of true and false. So either you can feed it this thing, false, false, true, true, true. If you feed that in the square bracket, okay. So this is also going to give you 5, 6, 5, 7, 9. And if you feed it, actually, if you feed it 3, 4, 5, if you feed it the exact indices, then also it's going to give you 5, 7, 9. Okay. So these are both the ways in which you can access the exact elements which satisfy your condition. Okay. Just a summary. Okay. All right. So, sorry. Yeah. So now we have discussed simple elements, okay, numbers and characters. We've discussed lists. We have discussed vectors, and we have discussed matrices. So now we come to another type of data. You can think of this as a special kind of vector. Seemingly, when you're just taking a look at it, these are going to look very similar to factors. They're going to behave very similar to factors in a lot of ways, but they also have an added functionality. Okay. Now, specifically when you are interested in making groups within a vector, okay, then, so let's say, a simple example, you want to make like you've taken a poll in the class, and you want to just ask that what is the favorite sport of people. Okay, so everybody is going to say different names. Let's say everybody tells you one name, so you are going to find commonalities, right? A lot of people are probably going to say cricket, a lot of people are going to say table tennis. So you can make groups, right? You can say that, okay, in a class of 30, cricket was the answer for 5 of them, table tennis was the answer for 4 of them, chess was the answer for 2 of them, and so on, right? So you have sort of made groups within a list, within a vector. So the initial data that you had, the answer from each person, it was a vector. It was a vector with 30 elements, right? Cricket, comma table tennis, comma cricket, comma basketball, comma chess, comma cricket, comma table tennis, and so on. But you can make smaller groups within them. So that is something that is going to be helpful. So such a data can be called as group data, or it can be called as categorical data. And you can in fact also say that, okay, I'm assigning the value 0 to you know or the level 1 to cricket, level 2 to chess. So basically you can just say that, it's like, in your table you have like a table somewhere written that the first sport is cricket, the second one is basketball, third one is chess, and so on. So you can sort of map it to numbers. The character as such does not have to be there. Okay. Cricket, cricket, is actually a character, right? It's a character name. So in fact you can refer to it as sport number 1, sport number 2. Okay, something like that. So this is where factors are going to be used. Okay, so now let's say, just similar to that sport example, let's say there was something that, this is each day of the week where we had the lowest attendance. Okay, so in week 1 the lowest attendance was Monday, week 2 Tuesday, week 3 Monday, and so on. Okay, so this is an example of 7 weeks. Okay, or whatever, yeah, 7 weeks. So you had this was the day when there was lowest attendance. Okay, now if I convert them into factors, because now what I'm interested in seeing is probably which day is usually the day with the lowest attendance, or which is the day when usually you have the highest attendance, or something like that. So I can define a factor, just writing factor, and the input to the function factor is going to be this vector. Okay, so if I'm writing this, so now you see the first line. So the output here, so there are two levels of information that you can say that the variable has. Typically let's say when you were writing this vector, there was just one line of output. It was storing information in just one line. But now there are sort of two parts to what information it's storing. So the first part is exactly the same thing that you gave as the input. Okay, except now you can see that there are no double quotes, right? The initial thing that you had, it had double quotes, but now there are no double quotes here. But apart from the double quotes, it is the same order, everything, right? Same number of elements, same order. And the second thing here is, it's saying that this is the unique elements that it could identify. Okay, so there's Friday, there's Monday sometimes. Okay, so it calls it one time. There's Saturday, and there's Thursday, and there's Tuesday. Okay, so now these levels are basically sort of unique elements, and they are arranged alphabetically. Okay, so first you have F, and then M, and then S, and then TH, and then TU. All right, so this is how you can just define the levels. Maybe you would be interested in so let me just give you an example. Okay, so we had Monday, Tuesday, there's no Wednesday here, Thursday, Friday, Saturday. Yeah, so maybe if you just want to jumble this up, in fact, I mean, instead of like not jumble, but if you want to make it in the order in which we normally refer to the days of the weeks, so you can just specifically say that the levels are Monday, Tuesday, Thursday, Friday, Saturday, right? So that becomes the second factor. So now you see here, again, this is exactly the same, but the factors here, they're now in your desired way. So you are going to say Monday as the first day of the week, Tuesday as the second day of the week. Here it was probably calling Friday as the first day, Monday as the second day, something like that. Okay. And but actually here we are missing Wednesday here, right? So which is why, but actually Wednesday is also a day of the week, right? We don't want to miss out on that. So you can specify levels to be more than what is actually present in your data. Okay, so it doesn't matter, your data stays the same, but your levels are fixed because these are the let's say 6 working days of the week, right? So that's also important. And yeah, so now just one more thing. So now if I add an extra information, which is labels. So now what it does is it's actually converting levels as well as the original data into these labels. So initially it was, the first thing was Monday here, right? So now it's actually, instead of calling it MON, it's calling it entirely Monday. So it's going to be both here and here. So you're just changing names. Okay. So yeah, missed this. Yeah, like that. Okay. So these things, the functionality is going to become more evident in the upcoming lectures, but this is how you are defining it. Okay. It's going to be useful in a lot of different ways. Again, like we discussed, if you want to make groups of some data, if you want to see how frequently something comes up, and when you have a fixed number of elements. Okay. Now, if you're writing numbers between 1 and 1000, uh, you're not really interested if the number 5 is coming multiple times. Maybe not, right? But usually, it's more common that you have factors for characters rather than factors for numbers. But of course, you can define that. So likewise, here you have this thing, let's say a vector G, and if you're defining the factors, so it's going to be in the same order like this. But the levels, so here we had seen that the levels are their unique names, they are arranged alphabetically, but here they will be arranged numerically in ascending order, right? So it's alphabetically for characters and ascending order for numbers. Okay. Now, taking one step forward from factors, sometimes the sometimes the order in which the factors are. So this where we did was Monday, Tuesday, and order is important, right? Because okay, Monday comes before Tuesday, which comes before Wednesday, and so on. But we are not exactly saying that Monday is less than Tuesday or Monday is greater than Tuesday, right? That sort of comparison doesn't make sense here. But there are cases where that sort of comparison may be important. So you're adding one more level to these factors. And now instead of using the function factor, you're using the function ordered. Okay. But there also, it's the same syntax. The first element is that list, sorry, that vector. And the second argument here, it's going to be levels, just like that. And you're going to write it in ascending order of what order they follow. And it's actually going to give you, so you see, light, strong, moderate, moderate. It's the same order here. But now you had it, the levels were light, moderate, strong, and you have given it in a certain, you've given a certain comparative narrative to it also. You're saying that light, that's less than moderate, that's less than strong. Okay. Again, this is just an introduction. This is going to be used more in the subsequent classes. All right. Okay. Now, do you remember this function? Okay. Now, if I write class, let's say I take a class for this thing. Okay. For W, we saw it. This is a vector. Sorry, this is a list, right? And the vector A here, so you're calling it integer. So basically, it's typing this thing, right? The one thing that comes here, right? Likewise, if I say class of so let's say, yeah, any of these factors, F1. So that's a factor, right? Now the so that's how you say it's a class. What type was the type of data that is in it. Okay, but now there's one more thing you can do here. If I say unclass F1, so now you see what was F1 initially. So this was the order, and this was the levels. Now what unclass does is it's going to replace the original data by the order of the factor. So what it's doing is, so the first element here is Monday, okay, MON, but that is the second factor. So basically it's saying Friday is equal to 1, Monday is equal to 2, Saturday is 3, Thursday is 4, Tuesday is 5. And it's going to replace these by these numbers. So this has become 2, 5, 2, 1, 3, 4, 2. Right? This is what it is. Okay. Likewise, now let's say I do this SFAC, and if I do unclass on SFAC, so before I run this, would you like to give it a try? What do you think the output is going to be? So light is going to be assigned 1, moderate is going to be assigned 2, strong is going to be assigned 3. Okay. Can you tell me what would the output here be? It's going to be a combination of 1, 2, 3.
Yes, it will be 1, 3, 2, 2, 1, 2, and 1.
1. Perfect. Yeah. All right, great. So this is what unclass is doing. It's basically replacing names, these factors, characters, into the corresponding order of the factors. So it can be just, again, it may be required sometimes. It's possible that there are some functions, some inbuilt functions in R which might not accept characters, but they can work with whether it's factor number 1, factor number 2, factor number 3, and so on. Okay, so internally, this sort of a conversion may be required. Okay, and so just one more example. So here we have this original thing, right? This was a vector. And now what I do is, okay, same thing. Okay, so now this is what I had assigned as my reference, sort of, right? Why did I write E here? Okay. Okay, so this is what you just said, right? That unclass F1 is going to give me an order of these things, 2, 2, 5, and so on. Right? Now, if I feed this thing days, it's just going to take in this order, right? Actually, there's a slight mistake. I should use F3 here. Right? So, yeah. So basically, there's unclass F3, right? Because F3 is this order: Monday, Tuesday, Monday, Friday, Saturday, Thursday, Monday. I can unclass it, and if I feed it to this, to days, it's basically going to take this vector and it's going to take out the elements. It's basically I'm accessing the indices of this vector. Okay, so again, this is one functionality of why you may want to do an unclass step on a list. Yeah, so Divya, again, these recordings, they're all on YouTube. So if you take a look at this thing here, problem solving session, at the bottom of your course page, and you click here on the lectures, you will be redirected to this Google Sheet. So after today's class, I'm just going to fill in this thing, right? The session is being recorded, so I'll just fill it here. Okay. Yeah. All right. Thanks. Okay. Okay. Now, I think this one is the last lecture of this week. So it's something related to some formatting. And if you remember, we had talked about a few things initially, right? Round, floor, ceiling, and all of that, truncation. Class function. Okay, so I think this was discussed in one of the initial classes, but basically class is telling you what is the type of variable, right? So if I say class A, so A was a vector of integers, right? If I say class of W, it was actually a list, right? If I say class of M, that's actually a matrix. If I say class of F1, that's a factor. So you can do an unclass on factors, right? Yeah. Okay. All right. So the final bit here, we are going to be talking about a little bit about formatting, especially formatting of numbers, but not just limited to that. So okay, yeah, so this is sort of an extension of what we had talked about in one of the earlier lectures, like floor, ceiling, truncation, and round, and all of that. So it's just a little bit more than that. So there are a lot of things that, so now typically what you can see here, if I write 22 by 7, let's say I write that, and I write print 22 by 7, it's basically the same thing, right? R has this option that if you have not, if you're not saving the output somewhere, it's just going to be printed here. This is what this is doing, right? So you don't as such explicitly need to use the print function. But let's say this thing, if you don't want 3.142857, if you just want it until 2 places or 3 places, or you want like 10 places, or if you want some more additional formatting, then you can make use of the print function to explicitly change the way it's being the way the output is being written. Okay. All right. So here, yeah, right. So this one we just saw, and now print. So you can check what all argument print offers. Uh, the lectures did not discuss all of them. All of them are also not necessary, right? But we'll just take a look at some of them. So for example, digits and justify, and this is what we'll see today. So now if you see digits, so digits mean, in general, this is not just talking about decimal digits, but the number of digits in the output. So if I say 4, then there are only going to be 4 digits, except the decimal place itself. 4 numbers only in the output. So which is basically going to be 3, 1, 4, 2. Right? So if I write digits, okay. And did you see here? So when I say DI, and I can press a tab here, sometimes R is going to predict on its own. And if it's not predicting, you can just press tab. So it's going to predict what all options it has. It's just simpler, especially when you are using RStudio. I'm not sure how extensive this functionality is in our console, the R default. There is an option, but it's not very user friendly. But anyway, so this is just, it's just going to make it slightly simpler if you don't remember if it's capital or it's lowercase. But of course, this is not from the purpose of your exam. There you won't have R or RStudio, but this is when you're using R in general. So okay, so when I write digits here, so it's going to take 4 digits. So that includes everything before and after the decimal. Yeah. Yeah. Okay, so this is definitely an added functionality of RStudio. because it's tough to remember so much, right? All right. So this is one option. So now let's say, so similarly, you can, you, if let's say this is about numbers, but let's say you want to do some formatting in terms of characters. So let's say I have this vector with me, the vector L. So whether I write L or whether I write print L, it's going to be the same thing, right? Now, there's this option format. So can you see there are a few differences between print L and format L, right? So what print L is doing, so there are these, so each of them is an element, right? Each of them is a character here. So you have 5 elements in the vector L. But now what format does is, these double quotes, it's sort of fixing um, the number of characters within each double quote. And the largest one, which is September here, which has how many? Nine places, 9 characters, 9 alphabets. So it's able to accept 9 alphabets in each of them. So if you sort of are able to count the spaces and everything, so each of this totals to 9. Okay. So somehow this is how what the default is. Okay. But you can remove this by saying justify is none. Okay. So now you see format with justify none gives you the same output as print. Okay. But now that so each of them here, it's taking multiple spaces, and you can see that this is aligned to the left side. So you have white spaces on the right. Now this is very important when, let's say, so I'll just give you an example. So let's say you have like a scatter plot. Okay. This is what a scatter plot means, right? Now you want to write the name. You want to say that, okay, these are actually names of countries. So you are writing this is India, and whatever, this is USA, and like that. But now let's say instead of USA, you wanted to write United States of America. So it's going to be a long name. Now, do you want the name to be like this? Do you want the name to be like this? Do you want the name to be in the middle? So there are these 3 options, right? You want it to be aligned to the right side, in the middle, or to the left side, right? So that option, that is something that this sort of a formatting can assist you in. Okay. So instead of writing none, you can say it's on the left. So this is how it was originally, right? You can say it's on the right. So you see now the blank spaces are on the right side. You can say it should be on the center. Now just be careful with the spelling of center. It's CENTRE, right? So you can have roughly equal number of spaces. So of course, for example, here you have, I think, 3 spaces. So here you have 4 spaces, like that, but it's relatively in the center. Okay. And now here we said that this whole space that is assigned to these words, this was equal to the largest word here. But you can even increase it further. So you can see that now you've increased the space to 12. So this was 9. You have 1 space on the left, 2 spaces on the right. And here also you can have center, left, right, or none. Okay. All right. So this is format function. Now, in addition, the format function can also be used to format numbers a little bit. So now if you have this number, which is like a really big, I think there are, I don't know how many, 9 or 10 zeros here. So if I write this one by default, now this can be a bit different across our console, as in the R default or R studio, because I think in the lectures that Sir showed, this was getting printed just like that. It was not being printed as the scientific notation. So 1 into 10 to the power 10. But so anyway, so if I actually do this, if I want to separate this in, so normally, so it's just more difficult to read. So I just want to incorporate commas. So if I just write it like this, actually it's not making any difference. Okay, it's still saying um it's just the scientific notation with it's now a character. So something did not work right. So just a sort of a way around this is, I'll say format this number, but don't write it in the scientific format. So it's writing it in this format. And now I'm saying that you separate it with commas. So now it's able to separate. And of course, this is a format. So it will still be in double quotes because numbers normally they don't have commas in them. So when you are separating them by commas, you will not be able to do any mathematical operation on them because they are characters now. Okay, remember that. But nevertheless, it becomes simple to read at least. Okay. All right. So this is just an added thing. It's not necessary that on your system this may be required. I have not been able to figure out if it's some setting that I've done or if it's our version specific thing. But anyway, so to be separating things by commas, you will need them to be not in the scientific notation, right? This e to the power. So this basically means 1 into this e here stands for 10. Okay, it's not the mathematical e, but it's just exponent in terms of 10. Okay. All right. Okay, so next up, just a few more things with respect to the decimal place. So there's this argument in format called n small. This is specifically focusing on the decimal points, right? So you remember in print there was digits. This was focusing on all the digits, but sometimes we just want to have a constraint on the decimal points. So so let's say I'm saying format 2 with no decimal point. So it's going to be 2, right? But now I can say, if I say a decimal number with no decimal point, then it does not work because it does not want to lose any information, right? On the other hand, I can say if I want to have multiple decimal places, so it's just going to add that many zeros to it. All right. Okay. And format also has the option of digits. Okay. So you can see this thing here. What it does is digits is actually not making any difference. Okay. So digits is like it's like an upper bound. You can have maximum 6 digits. Okay. But n small means you should have 6 decimal places. Right? So this means should have 6 decimal places and can have maximum 6 digits. Okay, this is what you can interpret from here, right? This will be more evident when you can see this example. So if I have like a long number, if I say digits, then it's going to say, okay, it can only have 6 digits. That's all. Now, can you think what these two things are doing? So here I'm saying that this number can only have 6 digits. But I'm also saying this number should have 10 decimal places. Okay. So, I mean, there's a conflict, right? Should it have a maximum of 6 digits? Should it have at least like 10 decimal places? A total exactly 10 decimal places? So what you can see from here, from the output, is that you should have like n small, this argument has a higher preference than the digits argument. So basically it's sort of neglecting this. It's saying, okay, I should have 10 decimal places. So it's just adding an extra 0 here. right? And this n small here, this can actually have a maximum of 20 only. So if you sort of try to write 20 here, oh sorry, if you try to write like 21 here, it says it's invalid. But now actually if you see this thing here, when it says like 19, it's adding some random numbers at the end, and I've not been able to figure out why is that happening, right? I mean, I would expect there to be just 000 until the end, until the 19th or the 20th position, but it's just adding some random numbers. I don't know why that's happening. Okay, so n small can be maximum 20. All right. So yeah, that's pretty much what was taught in this week. I hope I've not missed anything. And I just have a few questions that we can practice that will give you like a even quicker recap of the whole thing. But here I would really like you all to participate. Okay, right? I think there's just 5 or 6 questions, not much, or maybe 7. But yeah, not a lot of questions. Okay. So yeah, so if you're assigning list x1 is 5, comma 6, how can you assign the name to the second element? Can you tell me what command you're going to write? There are no options, so you can just tell me. You can tell it to me first that what do you want to do exactly, and then we can write the appropriate code for it. Okay, this one's not a very simple question. Okay, so do you remember what all functions are we going to use for this, even if it's not in the right order? Anybody? Good. So just reverse the arrow. Okay, so there are a couple of errors here, but it's a good try. It's a very good try, right? So first of all, the function is actually names. Okay, so you are right. You'll first say that names of x, right? Now, out of the names of x, so there are 2 elements in x, right? The first element, which already has a name x1, the second element, which does not have a name. So out of the 2, yeah, okay, no worries. That's okay. Now, out of the 2, we specifically want to go for the second element, right? So this is where we are going to write the square bracket. And now we want to assign x2 to it, right? Your answer did not have the name x2. So now we want to assign x2 to this thing. And this arrow, you understand, right? It's the assign symbol, the less than and hyphen symbol. Okay. So step by step, you see the names of this list. From the names, it's the second name that we are interested in that we want to assign. So we assign x2 to this second name, second element of the names vector. Okay. All right. Okay. So there are 2 very related. Just it's a very simple question. You have a list which has 1, 2, 3, 4, 5, 6, 7 elements. Okay. I have missed this bracket here. Okay. All right. So this is the list. So what is the correct output of the command? If I write append 200, what is going to be the output? So basically, where is this 200 going to be fitted? Yeah. So I will have 7 elements. So it's basically going to look something like this. It's the first element. So here you're going to write UP, right? Like this. And so on. You're going to have all of this. And then at the 8th position, the first or the only element that you're going to write is 200, right? Question 3, 200 is going to be at the it's not going to be the 4th element, it's going to be after the 4th element, right? So it will become the 5th element actually. So here it's actually going to be at it's going to be the 5th element here, right? And then all the way until 8, because it's after 4. So the 4 elements, so you had like you had 7 elements. So after the 4th element, that becomes the 5th element, and then you have 3 more. Okay. Yeah. Is that all right? Yeah. Okay, great. Okay. So what is the output of the command factor and these elements? Which of the 4? A? Are you sure? Are you sure it's not C? Yeah, okay. Just messing with you all. So yes, the correct answer is A. Right? So the first line is exactly the same as what you fed it. And the second line is levels, and you'll just have the unique elements, and they will be arranged in either the alphabetical order or they'll be in ascending order. They're not going to be by default in the order in which you gave it. Okay, so had it been 20, 20, 10, 10, 30, 30, and then in that case also the levels would have been 10, 20, 30. Okay. All right. And oh, it's actually the same thing. So for most of the cases, factor and as dot factor, they are very similar commands. We've not gone into as dot factor, but for the purpose of today's discussion and until this week, consider them to be the same thing. Okay. So if they are the same thing indeed, what will the output be? Option C, right? Great. Okay. Yeah. Okay. So now here you have the variable data. You are initializing it. This is a vector. And now this line is where you're printing factor data. Okay. So there are 2 parts to it. Okay. I think I've just missed a few lines here. Okay. Okay. So the first line that you're printing is factor data. When you're converting it as a factor, what is going to be the output, right? So, yeah. So out of the first line, you can say it's either going to be option A or it's going to be option B, right? So this 2 lines, this is you're sure of. Now the next statement, what it's doing is that you are assigning levels to this one. You're saying that now you assign the level A and B and C and D, right? So now it's basically going to be, now you see, you did not save that as factors. You did not save data back. You're just assigning levels to it, right? So, so now what it's going to be is something like this. the levels, the first one 4, that becomes A, the next one 2, that becomes B, the next one 6, that becomes C, and the last one D, 9, that becomes D. Okay, so you're assigning, so basically it's these 2 steps and these 2 steps. Okay, I'll just show this. I think levels I did not discuss today, so let me just copy this whole thing. Okay, so now you see, so we have this, right? So this is data, right? This was the original thing. Now I print this as the factor, right? So naturally, this is what we discussed. If you make it as a factor, you're going to have the levels. By default, the levels are going to be in ascending order. But now I did not save this back into data, right? So if I write data, it's still the same thing. It's not factors. So this step, you can basically assume it's not there. Now what I'm saying is I'm assigning the levels of data as ABCD. So what this is doing, it's basically saying that this A is now being, so this is actually A, this automatically becomes B, this becomes C, this becomes D. Now it's no longer in this alphabetical or increasing decreasing constraint. Okay, so that's what levels is doing. It's not exactly converting this thing. Okay, so it's not like factors. Okay, so now you can see, okay, so it's basically this thing. Levels is actually incomplete if you assign it without factors. Okay, so it's this thing. Okay, and I think this is the last question. Yeah, so which of the following is the correct output of the command? Okay, so now again there are a lot of things happening here. So now you see, I'll just color code the brackets. So you see this bracket is with this bracket here. This C has this bracket, and this C has this bracket, and let's say, yeah, the last one is black. Okay, so it's this final bracket. Okay, so now what we are doing is, so you have a vector which is high school, graduation, post-graduation, graduation, high school, post-graduation, high school, post-graduation. You're converting this as a factor, and you're assigning the levels to be high school, graduation, post-graduation. And now you're doing an unclass on this. Okay, that's very quick. Okay, so now you see that high school. So right, so now basically the factors are going to be converted into, so these elements are actually going to convert it into the corresponding factor order, right? So high school will be called 1 everywhere, graduation will be called 2, post graduation will be called 3. So it's basically high school. So it's going to be 1, 2, 3, 2, 1, 3, 1, 3, like this. So you can just check. This is what is fitting the order. All right. And that's all. I don't have another question. Okay. So we don't have a lot of time. So I'll just quickly go to the assignment 7. Do you have any questions before we go to assignment 7? Yeah. Okay. This assignment was not, so I mean, the questions, I think they are, the solutions are relatively straightforward. So yeah, this one where you have to generate a sequence of 3 dates year wise, you can just have the by year option, right? From to by year. Then for 8 months, starting from 12th March 2020, so it's this one by months, and a total of 8 such elements, right? This thing here, so letter is not the variable, letters, it's plural, which is why it's going to give you an error. And letters capital, so you're basically taking the 18th letter to the 12th letter, like in the opposite order. So that's R, Q, P, O, N, M, L. And then the correct command of this thing, so it's 3, 4, 5, 6, and you're repeating that 3 times. So 3, 4, 5, 6, 3, 4, 5, 6, 3, 4, 5, 6. And same thing here until 75 to 70, again 75 to 70, and 75 to 70. And this one is actually 45 being repeated 4 times, then 44, and then 43, and then 42. Okay. Yeah. So this is also the same example. It's very similar to what we saw today, that if you are feeding a matrix into rep, it's going to be read as a vector column wise. Okay. So this matrix, so by row is false, that means it's going to be filled by column. So it's going to be 1, 2, 3, 4, 5, 6. And that's exactly what is going to be your vector, 1, 2, 3, 4, 5, 6. And each is 2. So 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. Right? Please stop me if you feel I'm rushing through. Okay, just let me know. Okay, so then the output of this thing. So class 1, class 2, class 3, 3 times. Again, straightforward. 3 things are going to be repeated thrice, right? Okay, and then sort. So you remember sort and order are 2 different functions. So sort is actually sorting these elements in the decreasing order. So you're just writing it, sorry, here it's decreasing is false. So in the ascending order, so you have the smallest number until the largest number. This is the opposite. So largest to smallest. This one is order, wherein you are writing the positions of the smallest to largest or largest to smallest numbers. So here it's decreasing false. It means it's increasing. So basically you'll write the position of element 33 first. So that's 4. And then it's 38. So that's 3. And then 49, which is the 8th element. And then it's 61. No, it's, yeah, 55, which is the first element. And then 61, which is the 9th element, and so on. So sort and order. Sort actually tells you the elements, and order is telling you the positions of these elements. Right? Same thing here with the decreasing thing given here. So these options there, these are opposite of each other, right? Okay. And then which is going to be the correct outcome of the command mode. So here, if you see the vector that we have, this has a mix of numbers and characters. So like we said, vectors can only have one type of data with them. So it can only have, so it's going to convert numbers also into characters. So everything is going to be characters. So the mode is going to be characters here. Okay. And so which of the following is the correct output of this command? So X is a list, and this is the first element of the list. This is the second element of the list, and this is the third element of the list, right? So with this, we are accessing the second element. So that's from 20 to 37. So it's a simple vector. Yeah. So here now this one, it's I think this is the same. Yeah, it's the same list. But now what we are doing here is we are accessing the third element of the list, and from there we are accessing the third element. Okay. So here basically what you have is rep 8, 9, 8 to 10, each is 3 times, each is 2 times. So it's 8, 8, 9, 9, 10, 10. So the third element is 9, right? 8, 8, 9, 9, 10, 10. The third element is 9. Okay. Which of the following is the correct outcome of the command 1, 5 here? Now you see, had it been double quotes 1, double square bracket 1, then it would have probably made some sense. But here you've not written that, so it's not going to have this. There's nothing of this sort in this list. You cannot access elements like that. Okay. Now, which is the correct outcome of x3? So now here we had seen in the last lecture, you can recall that this is not the most perfect way to access, but you can still access it. Okay. But you should always try to not access it using a single square bracket. It should always be a double square bracket. Okay, since there is no null option here, so this is the next best option. But this is slightly like not the best outcome. This is going to work, right? So if you let's say if we had this one, so like we said that this is how you will access the fifth element. But even if you access it with this way, you will get the output. It will look slightly different because it's still going to retain its list nature, but it's not incorrect. Okay, so this is there. And so list, again, 3 elements. So here also, if you have a named list, you can access the element using its name. Again, it's going to retain the list nature since you just have a single square bracket here, but that is what it is, right? It's 10, 11, 12, 13, 14, 15. And likewise, the same thing here, the third element. But now you remember, you see 2 plus 4 plus 9 is written in double quotes. So it's not going to be added, right? You're not going to give the outcome as 15, right? Yes, you'll have very similar questions in the exam, right? The nature of the question is going to be very similar to this. All right. Yeah, so that's it. Okay. So yeah, I'll just upload the recording in a little while. And this PPT and this R script I'll also upload on the Google Drive. The deadline for this week's assignment is tomorrow. So don't forget to complete that. And then we'll again meet next week on 26th. All right. Yeah. Okay. Any questions? Yeah. All right. Okay. Thank you so much for attending this session and all the best. See you next week. Bye-bye.